So let's do a very interesting question that I found. Find the number and sum of all devices of 129,600 that are divisible by 180. So for this question, we'll be using the following properties. That is, if a number is of the format of p1 raised to alpha 1 times p2 raised to alpha 2 times p3 raised to alpha 3 dot 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 pk raised to alpha k, then the number of factors will be equal to alpha 1 plus 1 times alpha 2 plus 1 times alpha 3 plus 1 and so on, and then alpha k plus 1. The sum of devices will be 1 plus p1 square plus and so on up to p1 raised to alpha 1 times 1 plus p2 square plus and so on up to p2 raised to alpha 2, and then dot 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 1 plus pk square plus so on up to pk raised to alpha k. So we'll be doing some tweaks to these as we continue. So let's get started. First of all, we need to prime factorize 129,600. So 129,600 will be equal to 2 raised to 6 times 3 raised to 4 times 5 raised to 2, and 180 180 will be equal to what, 2 square times 3 square times 5, I think. Yeah. So what we have to do is that here we are finding the exponents, the possibility of exponents of the p1 raised to alpha 1, that is 0, 1, 2, 3 and so on up to alpha 1. That is what we are multiplying here. So in our particular situation, um, we have limited options. So as you can see, if it needs to be divisible by 180, then the only options for the powers of 2, 2 square, 2 raised to 3, 2 raised to 4, 2 raised to 5 and 2 raised to 6. So there are 1, 2, 3, 4, 5 options for the powers of 2. Similarly, for 3, there are 3 raised to 2, 3 raised to 3 and 3 raised to 4 as our options. So there are 3 options here. I'll just move the 3 downwards. So the next is 5, and for 5 we have 5 and 5 square. So we got 2 options here. Alright, so the total number of factors of 129,600 that are divisible by 180 will be equal to 30. So let's just write that down. The number of factors, of 129,600 that are divisible by 180 is 30. And now the second part of the task asks us to find the sum of all those devices. So we will continue with this particular formula with a tweak. That is, here the possibility of the powers of primes is limited. That is, here I'll just remove this and I'll do that. The sum of these devices or factors will be equal to 2 raised to 2 plus 2 raised to 3 plus 2 raised to 4 plus 2 raised to 5 plus 2 raised to 6 that's for 2, times 3 square plus 3 raised to 3 plus 3 raised to 4, that's for 3 raised to, sorry, that's for 3. And for 5, there is 5 and 5 square. I had to sum this here, okay? So that will be 4 plus 8 plus 16 plus 32 plus 64. And this will be 117 if I add all those up. And this will be 30. We just need to find this. And that will be 124. When you take the product of this, you will get the sum of divisors. You can multiply and check. The product will be 435240. So that's it. And this is the sum of the divisors, and this is the number of divisors of 129,600, such that those factors are divisible by 180. Those are the answer to our question.